The most interesting findings of the investigation, that's a good question. There's a lot of them, and I think I'll focus on maybe the three biggest ones I think that are quite cool to know about. So the first one is a midwater sulphide layer, and it's the most bizarre thing when you see it underwater. So in 2019, we were diving just for some routine monitoring, and we came across this really smoky layer at about 14 meters deep, and it went to about 18 meters deep, and it formed this thick white cloud, and it was really spooky. As you dropped through this layer, everything just went white, and you popped out on the other side, and you're like, whoa, and you look up above you, and it looked like there was just clouds of smoke. And this is a sulfide precipitate, and this has happened around about autumn every year since 2019, and as far as we know, we're still the only people to have caught this event on video, so that's quite a cool thing. And how this forms is quite interesting. I won't give you the full story because it's quite a long explanation. But to summarize, when the lake stratifies, you get a whole lot of really warm water at the top, and you get a whole lot of dense cold water, the water in the bottom parts of the lake. And then the hot water sits on top of the cold water. So when the hot water sits on top of the cold water in summer, and you have all of the algal species and all of the phytoplankton in that top warm section, they all reproduce and keep recreating, and you get more and more of them. As they die, they sink, but they can't sink past this deep, cold layer of water. So they sit on the top of what we call the thermocline. And once they're sitting there, they start decomposing. And this decomposition, again, pulls oxygen out the water and causes a sulfide precipitate. It's a little more complicated than that, but in general terms, that's kind of what's happening. You've got this large amount of organic matter from phytoplankton and plants sitting on top of a dense layer of water, and then that keeps decomposing, and this forms this really smoky sulfide layer. So that was probably the most interesting, unexpected thing that we found in that lake. Another one, which is pretty dramatic, is the complete extinction of freshwater mussels. And we know historically that freshwater mussels occurred in this lake, and there were two species. There was Echidna menziesii and Echidna aucklandica. And we've been looking for probably the best part of 2 years to try and find decent mussel beds, or at least decent mussel shells. And we started doing full digging up surveys, like excavations, and we were finding these historic mussel beds that were about 200 meters square, just full of dead mussel shells. And this was a shame because it gave us an indication of how many mussels were once in that lake. And we estimate they're probably in the region of about 40 to 50 mussels per square meter, which is huge, right? And they can filter about a liter of water per hour. So if you think about that many mussels across a whole lake, all filtering water at that rate, they would clear up the lake in a matter of weeks. So all of a sudden, that entire filtration capacity of the lake is now gone. And since 2017, we've been looking multiple times per year and still have not found a live mussel or even an intact shell, which means these mussels died, well, decades ago. So we've seen a complete extinction in those, and that's a massive shame that we've lost such a pivotal species from that lake. And then the last thing is probably the macrophyte extent and the loss of macrophyte extent. So macrophytes are plants that grow in the lake, and the extent is measured in terms of the deepest point that you see these plants grow. So this we use as an indicator for a whole lot of things. So the deeper it goes, it means the more light penetrates to the deeper parts, right? Because plants need light. So before 2017, we were looking at macrophyte extents down to 12 meters. So this means lots of plants were growing up to a depth of 12 meters or more. Since then, in the 3 years that we have been doing annual macrophyte surveys, we've seen a reduction down to 6 meters. And in 2020 was our last macrophyte survey, and that still comes back at 6 meters. So that means now the maximum depth that we've seen plants grow in is 6 meters. That's half of what it used to before. And, that's a pretty dramatic sign that something's going wrong here. And yeah, those are probably the three most surprising things for us. And I mean, it's a bit doom and gloom, but those were results that we weren't expecting to find.